Okay, let's look at question 4. Question 4 is a graph question. We are asked to complete the table of values for this expression over here. Y equals to 2 over x squared plus 3x minus 1. Values are given to 1 dp where appropriate. Okay, so right off the bat, you see this graph here, you're missing one value, right? You're missing this value over here. So what can I do? I know that the x value is minus 3, right? I can just sub it back into my equation. So y, the working would be y equals to 2 over minus 3 squared plus 3 multiplied by minus 3 minus 1. Okay, so key the whole string of numbers into your calculator. You will get a number of negative 9.8. Okay, so negative 9.8, this would be my first coordinate. So just to recap, how do we read these values? Let's say this is my first set of numbers. It would be minus 3, comma, minus 9.8. Okay, so you plot it. This is my x value. This is my y value. Okay, and I think the graph is given to you really nicely. The plots are given, like the number lines are given. So you do the same. Draw all your plots, draw all your points, and then connect them together. So the blue line, it's the answer for my part B. So this is my equation. Y equals to 2 over x squared plus 3x minus 1. Okay, so good to label your graphs as well. Okay, so this graph, do you notice that actually over here, a bit unique, over here, notice that I don't connect these two dots. Okay, so why can't I connect these two dots? Because you have learned this before, right? This is your reciprocal graph, right? I can't just connect them together. It must be two separate graphs. Okay, why is it a reciprocal graph? Because of this function over here, this fella. Okay, so 2 over x squared. Okay, so you don't connect the lines, you just leave it as two separate lines going, away from each other. Okay, next, on the same grid, I need to draw the graph of 2y minus 5x equals to 7 for a range of minus 3 to 3. Correct? So this graph, this line over here, this would be a linear function, right? It just looks like a straight line, right? How do I know it's a straight line? Actually, if I move my terms around, I can actually get an equation of y equals to mx plus c. Okay, so how do I do that? Let's move my terms. So 2y minus 5x equals to 7. I move the 5x over, so 2y equals to 5x plus 7. Okay, so minus 5x, you bring it over, it will be positive 5x. Okay, I want to make y my subject. So to make y my subject, I need to bring 2 over, so 5 over 2x plus 7 over 2. Now, compare this equation with y equals to mx plus c. Do you see the resemblance? Yes, so 5 over 2, it's my gradient. This 7 over 2, this is my y-intercept, or also known as c. Okay, so how do I approach this question? Right, I need a graph from minus 3 to 3. Right, so I'll do the same thing as whatever they did for me before, x and y. I'll draw a plot like that. Okay, x and y, but I don't need a lot of numbers actually, right? I just need a minimum of 3 numbers in order to make this work. Okay, so what 3 numbers do I want to use? Maybe let's use the very end and the very end. Okay, so minus 3 will be my starting point. 3 could be my end point. And what's in between minus 3 and 3? Very simple, it will just be 0. Right, so key into your calculator, if x equals to minus 3, y, what do I get? I will sub it into this equation over here. Right, this is the equation that I have simplified out. I can use this. Okay, key this into your calculator. You will learn that y equals to minus 4. When x equals to minus 3, y is minus 4. When x equals to 0, y would be 3.5. When x equals to 3, y would be 11. Okay, so these 3 points more than enough, right? So more than enough to draw my line over here. So same thing, I will plot out all my line, and it's actually this green line over here. So this one would be my 2y 2y minus 5x equals to 7. Okay, so this is the green straight line, y equals to mx plus c line that I'm talking about. Okay, so yeah, this is how the two graphs should look like. Okay, let's move back. So write down the x-coordinates of the point where the line intersects the curve. The line intersects the curve. So where does the line intersect the curve? There are actually 2 lines. 2 points, I mean, sorry. Here, do you notice? And here. So these 2 points. Okay, so how do I get the x-coordinate? I will just use a ruler and read off the value. Okay, Oh, the ruler is not showing up. Okay, yeah, so you just read down the value. So let's say this point I have, the do the dot thing, and then read off this value. Do the same thing for here, dot, go down. What is this value over here? Read off. Okay, so read off from your own graph. The answer that you should get should be x equals to 0.7 and x equals to negative 0.65. Okay, so these two answers are the recommended. I think that they will accept within a range as well. Okay, so just make sure your numbers are as close as these two as possible. Okay, next, these values of x, so these two answers, x equals to 0.7 and x equals to negative 0.65, are solutions of the equation x cubed plus ax squared plus b equals to 0. Find the value of a and the value of b. How do I do this? Right, so if you look back at how did we even get these two numbers, it's when the equation, this reciprocal equation is equal to my 2y minus 5x equals to 7 equation. Does it make sense? Yes. It makes sense, right? Because it's where they intersect, right? It's where they intersect. That means the x values must satisfy the left-hand side, must also satisfy the right-hand side. Okay, so what I can do is I can rewrite them out, right? So let's say 2 over x squared plus 3x minus 1 equals 2. Okay, so instead of using this equation, I formed it into y equal mx plus c, right? So maybe I try to use this. This looks easier for me to use as well. Okay, so equals to 5 over 2x plus 7 over 2. Okay, right. So at this point, it's where the x is the same for the left-hand side. The x is also the same for the right-hand side, right? So basically the points of intersection. Okay, so now all I need to do is just solve, right? So, but how to solve? There's a lot of things going on. There's a lot of fractions as well. Maybe let's try to get rid of, maybe the first guy, this one, this x squared over here. This looks very ugly, right? So what can I do with this x squared? I could multiply everybody, right? I could multiply everybody by x squared. Okay, so from here to here, what will be my first step? I will multiply by x squared. Okay, so 2 multiplied by x squared, I will get 2. Okay, because x squared will cancel out, so that I just remain as 2. Next one, 3x times x squared, I'll get 3x power 3. Okay, here is power 1, here is power 2, 2 plus 1 indices, you will know it's power 3. Minus 1 times x squared, you get minus x squared. Okay, on the right hand side, do I also need to do the same thing? Yes, right, I also need to do, right? So if I multiply by x squared on the left, I also need to do the same thing for the right. Okay, so don't forget about that. Okay, so same thing. 5 over 2, x times x squared, you get x power 3. 7 over 2 times x squared, you get 7 over 2 x squared. Okay, x power 2. Right, so all our numbers are pretty okay. Maybe let's try to rearrange them together. Let's put all of them to the left-hand side. Okay, so let's go by increasing order first. So let's do the higher order. Okay, so the 3x power 3 minus 5 over 2 x power 3. Okay, I'll move all the power 3 over. Then next I'll do the power 2s. It will be minus x squared from here. And then 7 over 2 x squared, right? If I bring over, it will be minus 7 over 2 x squared. Okay, and then plus 2, which I never moved, so it will just remain as plus 2. Okay, so what? From here on, I can just simplify, right? So 3 minus 5 over 2, I will get 1 over 2 x cubed. And then minus 1 minus 7 over 2, I will get minus 9 over 2 x squared plus 2. Okay, now this looks very familiar like the equation that we have. Do you notice something? Yeah, sort of. Right, it looks similar, but it's not quite there yet, right? I need an x squared plus ax plus b. Right now, my x cubed, okay, my x cubed this guy, and my x cubed this guy. Over here, I got 1/2. Right, so how to get rid of the half? How to get rid of the half? From here to here, half is essentially the same thing as, maybe if I express it like that, it will be same thing as x cubed over 2, right? Half times x cubed, it will be x cubed over 2. So how to get rid of this 2? From here to here, I will multiply by 2. Right, so same thing as what I did on top. In order to get rid of the denominator, I multiplied by x squared, right? So over here, in order to get rid of this denominator, I multiply by 2. So everybody multiply by 2. Okay? First one, I multiply by 2, I'm left with x cubed. Second one, multiply by 2, I get 9x squared. 2 times 2, I get plus 4 equals to 0. Now this looks like very similar to my equation right now. Okay, so x cubed, yes. Ax squared minus 9x squared can compare. Can, right? So A, I can say that it's actually minus 9, and B would be a 4. Because this is my 4, this is my B, so A is minus 9, B is 4. Okay, so just remember this step over here. Yeah. Okay, so don't stop here. Continue on until you have x cubed, 1x cubed.